Welcome to the Deep Dive, where we cut through the noise and extract the essential knowledge you need fast.
We're here to be your guides through, let's say, dense topics and technical documentation, pulling out the valuable insights so you can get straight to being well-informed.
Exactly. And today we're plunging into something that is, well, absolutely fundamental for anyone working with data, but often feels like a massive hurdle: data preparation. Think about it, that process of finding, cleaning, structuring data. It's complex, it's time-consuming, and honestly, the sources highlight estimates saying it can eat up 60 to 80% of the time and cost on analytics projects.
Wow.
That's huge. Things like fragmented data sources, inconsistent formats, just getting everything integrated. It's a beast.
It really is the unsung hero, or, often the villain of data projects. And that challenge is precisely why Microsoft developed Power Query. Its core mission is to bring powerful, self-service data preparation capabilities right into the hands of users, aiming to make that wrangling process significantly more accessible and efficient than manual methods.
So here's our mission for this deep dive. You've provided a rich collection of sources, really drilling into Power Query and its underlying language, M. We're going to slice through all that technical detail and documentation to give you the most important concepts and features, the ones that make the biggest difference and maybe might surprise you.
Sort of the greatest hits.
Exactly. It's your accelerated path to understanding what Power Query is really about.
We'll take you step by step, starting at the very beginning, how Power Query actually gets your data. Then we'll move into the transformation engine, explore the powerful M language that quietly runs the show, and finally look at crucial practical aspects like performance, troubleshooting common issues like the dreaded firewall, and scaling up with data flows.
All right, let's jump straight in. You can't transform data if you can't connect to it in the first place. So phase one, getting data into Power Query.
Right. Whether you're working in Power Query Desktop or the online service experience, the general flow for getting data is remarkably consistent. You define your connection settings, handle authentication, get a data preview, choose to go into the query editor, and eventually decide where the query result goes. While the initial Get Data page might look slightly different visually between desktop and online, those fundamental stages are pretty much the same.
The connection settings.
Yeah.
That's pretty self-explanatory, right? Just telling Power Query where to look?
Mostly, yes. It defines the source path using various parameters. If you're connecting to a file, that's the file path. For a database, it's the server and database name.
Got it.
Each connector has its own set of required parameters to point to the specific data source instance.
And authentication, is that always required, no matter the source?
That's a critical point from the sources.
Whoa!
Authentication is indeed required for every single connection.
Everyone. Okay.
The method varies hugely depending on what you're connecting to. It could be Windows authentication, database-specific username, password, your Microsoft account, or even a service principal using Microsoft Entra ID, especially for, automated processes. But you always have to prove who you are and that you have permission.
Okay, here's one of those surprising nuggets the sources highlighted that I found really interesting. Singleton connectors. What's the deal with those?
Yes, singleton connectors. These are unique because they don't require you to provide any specific parameters like a file path or server name when you set up the connection.
Oh.
They're pre-configured within the environment to connect to one single instance of that service per environment. The sources mentioned Adobe Analytics, MailChimp, and Google Analytics as examples.
Okay.
Makes sense when you think about it. You're typically connecting to your Google Analytics account, not some variable path within it that changes per query. It just simplifies the setup for those specific services.
That's a neat distinction. So after settings and authentication, you get a data preview.
Exactly. The preview stage is designed to be very user-friendly. It pulls back a sample of the data, letting you see what's there and select the specific tables, sheets, or entities you want to import before you commit to loading everything.
So you don't pull in junk.
Right. It's a quick way to verify you've hit the right source and selected the right piece of it.
And then you decide the destination.
The primary destination, and the one always available regardless of the Power Query environment, is transform data. Choosing this loads the selected data into the Power Query editor, which is where the magic happens, all the shaping, cleaning, and refining.
Right.
In tools like Power BI Desktop, you might have options to just load directly without transforming, but transform data is the standard path when any prep is needed.
And just to round out getting data, the sources pointed out that in Power BI Desktop, you don't always have to start with the generic Get Data button. You can often connect directly from menus for common sources like Excel, SQL Server, or Dataverse.
Right, or even type data in manually or quickly reconnect using recent sources.
Just shortcuts, really.
Right, just different user interface pathways to achieve the same goal of bringing data into the editor. And speaking of connection specifics, the sources walk through a detailed example of connecting to an OData feed, which involves an OAuth flow.
Okay.
You enter the feed's URL, choose the organizational account method for oath. When Power Query initiates the sign-in, it actually sends a request with an empty bearer token.
Empty. Why?
Well, the expected response from the service isn't a success, but a 401 unauthorized, specifically including a www authenticate header.
Ah.
Crucially, this header should contain the Microsoft Entra ID URI that Power Query needs to redirect you to for the actual interactive sign-in and token exchange.
Wait, so Power Query effectively probes the OData endpoint first, gets told, unauthorized, but here's where you should go to authorize, and then it performs the sign-in. That's fascinating under the hood detail. It's
Really
not
steady.
just a simple enter credentials and go.
Precisely. It's a specific handshake mechanism required by that particular authentication flow to guide the client application Power Query, in this case, to the correct identity provider endpoint. Understanding details like that really helps when troubleshooting tricky connections.
Okay, so data is in the building. Now for the main event. Transforming data. This is where you take that raw input and mold it into something useful.
Welcome to the Power Query Editor. This is truly your workbench for data preparation. It's packed with tools to reshape, clean, and enrich your information.
Let's talk about some of the core operations. Headers, for instance. Seems basic, but essential.
Simple but essential. Promote headers takes the first row of your data and turns it into the column names. Demote headers does the reverse, putting the current headers back into the first row of data.
Okay.
The sources point out a small but important rule here. Column names must be unique in Power Query. If you promote a row that has duplicate values, Power Query automatically appends numeric suffixes like .1, .2 to ensure every column has a distinct name.
That's a helpful detail for avoiding unexpected errors. Removing rows is straightforward.
Yes, basic filtering to exclude rows based on conditions you define. Pretty standard stuff.
How about replacing values? I've certainly had to do that manually in spreadsheets before. Tedious.
Oh yeah. This is Power Query's built-in find and replace for column values. The example in the sources was cleaning up text by finding the string category name and replacing it with nothing.
Nice.
It's a quick way to standardize text data or remove unwanted prefixes or suffixes across the whole column.
And what if you have multiple pieces of information crammed into a single column, like comma-separated stuff?
That's where splitting columns comes in. A very common need. You can split by a delimiter, like if you have comma-separated or semicolon-separated values in one cell.
Okay.
Or, very useful for fixed width data, you can split by a fixed number of characters. The sources gave a great example. Splitting a column into account name, date, and units based on specific character positions.
Right, like old mainframe reports sometimes.
Exactly. Which would be a nightmare to do manually across thousands of rows.
That fixed layout split sounds like a lifesaver. Parsing data is another one mentioned. What's that about?
Parsing is used when a column contains structured text, like, say, JSON or XML within a text field.
Ah.
Power Query can parse that text string into structured values, records, or lists that you can then easily expand into new columns. The JSON example transforms text representations of JSON objects into M's native record type, allowing you to navigate into the nested data visually.
Okay, so it turns raw text into actual usable data structures. The sources also highlighted that Power Query is data type aware, offering different transformations depending on the column type.
Absolutely. If you select a date column, the ribbon contextually changes to offer date-specific transformations, like extracting the year, month, day, or even week number directly with a click.
Smart.
This type awareness streamlines many common transformations. The sources even included a handy data type conversion matrix showing which conversions are possible and how Power Query handles them.
Adding new columns seems like a core part of creating new insights. How does that work?
It is. And Power Query offers some really intuitive ways to do it. Column from examples is almost magical.
Oh, yeah.
You just give Power Query a few examples of what you want the new column's values to look like based on values in other columns, and it attempts to infer the logic or M formula needed.
Wow.
The sources showed examples creating a range column based on income values or combining first and last names into a full name. It makes common tasks incredibly fast.
That ability to infer logic from examples is very user-friendly.
It really lowers the technical barrier. You can also add conditional columns if the logic is more complex, defining a series of if-then-else statements, like setting a final price based on different customer groups, as shown in the source example.
So you can build quite sophisticated logic visually. What about combining data from different tables, appending and merging?
Those are fundamental.
Yep.
Appending queries is like stacking tables. You take the rows from one or more tables and add them to the bottom of another existing table.
Vertically combining.
Exactly. Useful if you have multiple files or tables with the same structure that you want to consolidate.
And combining files from a folder sounds like a very common scenario, like monthly reports dropped in a folder.
It's a fantastic feature specifically for that.
Mm-hmm.
Power Query can connect to a folder, see all the files within it, like Excel or CSV files, and automatically merge them into a single table, provided they have a similar structure.
Does it just assume the structure?
It creates an example query based on the first file it finds, which you can then refine if needed. That refined logic is then applied to all other files in the folder,
Nice.
and the source is recommended checking the source name column filter after combining to quickly verify that all the files you expected were actually included in the result.
That's a great validation tip. Good sanity check. Now, merging queries, this is effectively joining tables like
Yeah.
you would in SQL.
Merging queries connects two tables based on matching values in specified columns. The sources use the classic example of joining customers and suppliers tables on the country field to identify countries that have both.
The sources listed a whole range of join types. Can you give us the quick rundown? Inner, outer, anti.
Sure. M supports the standard join kinds. Inner only matches in both tables. Left outer, all from left, matching from right. Right outer, all from right, matching from left. Full outer, all from both. Left anti, only rows from left with no match in right.
The ones that don't match.
Right. Right anti, only from right, no match in left. Left semi, only rows from left that do have a match in right, but you only get the left table's columns. And right semi, same, but for the right table.
Lots of options depending on exactly what you need. Let's stick with the inner join example first. Customers and suppliers on country.
Okay, an inner join would only return countries that appear in both the customers table and the suppliers table. If a country has customers but no suppliers, or vice versa, it would be excluded from the result. Simple matching.
Okay. Now, the right outer join example with sales and countries joining on country ID. The sources highlighted that little message in the merge dialog. The selection selects X of Y rows from the first table. They said that's really crucial. Why?
Ah, yes. That message is your immediate feedback on the matching part of the join, specifically from the perspective of the left table. It tells you how many rows from your left table, sales in that example, found a match in your right table, countries, based on the join columns you selected.
Okay.
So with a right outer join, you know you're getting all rows from the right table, countries, but that message tells you how many of your sales rows were successfully linked. If the message says selects 3 of 4 rows from the sales table.
It means one sales record didn't find a matching country.
Exactly. You immediately know one sales row didn't have a country ID that existed in your country's table, even though all the country's rows will appear in the final output, with nulls for the sales columns for countries that had no sales.
Ah, I see.
It helps you instantly understand if you have orphan records in your left table that won't be included in the matched portion of the join.
So it gives you a heads up about potential data quality issues or join logic problems before you even see the full output. That's incredibly useful.
Exactly. It clarifies the outcome of that lookup step. Really handy.
Another intriguing transformation is unpivoting columns. It sounds like it flips data from a wide format to a long format.
It does. Unpivoting is used when you have multiple columns representing the same attribute across different categories or time periods, like individual columns for sales 2023, sales 2024, sales 2025.
Right, like cross-tab data?
Precisely. Unpivoting transforms these into just 2 columns, one containing the name of the original column, the attribute, like sales 2023, and another containing the value from that cell, the actual sales figure. It creates a name value or attribute value structure, which is much better for analysis in tools like Power BI.
And the unpivot other columns option.
That one's particularly smart, because if your source data gets a new column later, say sales 2026, that new column is automatically included in the unpivot operation the next time the data refreshes, assuming you selected the columns you want to keep it fixed.
That automatic handling of new columns is a huge benefit for dynamic data. And speaking of seeing the overall structure, the sources mentioned the diagram view.
Yes, the diagram view provides a visual layout of your queries and their dependencies, especially useful when you have multiple queries referencing each other or complex merge-append operations. It helps you see the flow at a glance, Can get complex, but it's useful.
Okay, we've covered the what and the how of transforming data in the editor. Now let's talk about the engine under the hood, the Power Query M language.
The M language is the absolute core. Think of every click, every button you press in the Power Query editor as just generating lines of M code.
Behind the scenes.
Exactly. It's the precise recipe or specification that defines your entire data transformation process, step by step. You can view and edit this code directly in the advanced editor if you want or need to.
And the fundamental structure of an M query is the let expression.
That's right. The let expression is crucial. It allows you to define a series of steps, assign names, variables, to the result of each step, and then in the final part, after the in keyword, output the result of one of those named steps, or combination of them.
So you can break down complex logic into smaller named steps, makes it more readable.
Exactly. And unlike some scripting languages, the evaluation order of those steps within the let expression isn't necessarily strictly top to bottom. Power Query figures out the dependencies between your named steps automatically.
Like a spreadsheet.
Yeah, much like cells in a spreadsheet recalculating when their dependent cells change. It evaluates what's needed when it's needed.
Let's touch on some basic M building blocks mentioned in the sources. Values and literals. What's the difference?
Well, literals are how you represent specific values directly in the code, like the word null, true or false, the number 123, text like hello world, or even hashtag .text for verbatim text that includes special characters you don't want interpreted. Values are the actual results produced by expressions. So 123 is a literal, and it evaluates to the number value 123.
And expressions.
Expressions are simply things that evaluate to a value. A literal is a simple expression, 123. Combining literals or other expressions with operators makes more complex expressions, 1 plus 2, or calling a function like text, upper, hello.
Identifiers are just the names we give things, like step names in the let.
Correct, the names assigned within the let expression or function names. They can be regular names like source or added custom column, or quoted identifiers using hashtag and double quotes, like hashtag column name with spaces.
Ah, so you can handle spaces in names.
Exactly, which you often need when dealing with source data.
Standard comments apply too, like Amaro.
Yes, single-line comments start with, and multi-line comments are enclosed in do for adding explanations to your M code. Always a good practice.
The sources listed a wide array of key value types in M. Seems pretty comprehensive.
M has a rich type system. Null, logical, true, false. Number, time, date, date time zone with time zone info. Duration, text, binary, list, which is like an ordered array. Record, a set of named fields like an object or a single row.
Okay.
Table, basically a list of records where each record has the same field names defining columns. Function itself is a type, and type itself is a type for defining types.
Wow, okay. Understanding those helps you know what operations are valid, I guess.
Definitely. Operators like the math symbols.
Yeah, plus, minus, etc.
M has standard arithmetic plus M equality
Right.
and relational operators. Pretty standard.
And that operator is interesting because it does different things depending on the context.
Yes, it's overloaded based on the types it's operating on. For text values, it concatenates them, joins them together.
Like A and B becomes AB.
Right. For lists, it concatenates the list together. And for records, it merges the records. And importantly, if there are fields with the same name in both records, the field from the record on the right side of the herb and takes precedence and overrides the field from the left.
Oh, okay. That merge behavior is a key detail to remember when combining records. The order matters.
Absolutely. That's a specific behavior to watch out for.
What about error handling in M? What if something goes wrong in a step?
M has a very useful try expression. Instead of your script just stopping or erroring out when something fails, try allows you to attempt an expression, and if it fails, catch the error gracefully.
How does that work?
The try expression always returns a record, whether the original expression succeeded or failed. This record contains fields like has error, a logical true-false, value, the result if successful, and error, another record with details about the error like message and reason if it failed. This structure lets you programmatically test if a step worked and handle potential errors within your query logic. Expression. Error is a common reason code for errors generated by the engine itself. You can use try with your own custom logic, like an if statement checking has error, to build robust transformations.
So you can make your M code resilient to potential data issues, like bad data in a row that might cause a conversion error.
Exactly. Instead of the whole query failing, you could say return null or a default value for that row.
Yeah.
The sources also mention concepts like immutability.
Meaning values don't change once created.
Generally, yes. Once the value is computed, it doesn't change. However, functions that interact with the outside world, like reading a file whose contents might change between runs, or getting the current date and time.
Those aren't immutable.
Right, they can introduce non-determinism because the result isn't guaranteed to be the same every time the function is evaluated. Also, the order sub-expressions are evaluated within an operation might not be fixed. If one raises an error, that error is returned immediately, which can make evaluation order observable and potentially non-deterministic if you rely on side effects, which you generally shouldn't do in M.
Got it. And all of this M code leverages a massive library of built-in functions.
Absolutely huge.
Yeah.
M has hundreds, maybe thousands of standard functions covering almost every data transformation need. You can imagine functions for dates, numbers, lists, records, tables, text manipulation, connecting to specific services, error handling, diagnostics.
So lots to explore.
If you can think of a data operation, there's probably an M function for it, like date.tex is for formatting dates, number.sort for square roots, for summing list items, or the fundamental table.add column, which is used all the time, even by the UI buttons.
It sounds like the M language is the key to really mastering Power Query and doing things the user interface maybe can't easily do or doing them more efficiently.
It definitely provides that deep control and flexibility. But let's shift gears from the language itself to the practical reality of making your queries run efficiently and troubleshooting when they don't.
Performance and troubleshooting, the practical side. Always important. And the most critical concept here seems to be query folding. You mentioned it earlier.
Query folding is Power Query's secret weapon for performance. It's the process where the M transformation steps you've defined are translated back into the native query language of the source data system, like SQL for a database, for instance.
Okay.
Power Query then sends this native query to the source database to be processed there, rather than pulling all the raw data into the Power Query engine and transforming it locally.
And why is processing at the source better? Seems obvious, but let's state it.
Because databases are typically optimized for querying and processing large volumes of data efficiently. Pushing the transformations back to the source minimizes the amount of data that has to be transferred over the network to Power Query.
Right. Less data movement.
Exactly. If you can filter and aggregate data on the database server before it even leaves, you dramatically reduce the data volume Power Query needs to handle, which is usually much, much faster.
But I've heard not everything folds. That's the catch, right?
That's the challenge. Not every single transformation step you perform in Power Query can be translated back into a native query for every single source. Some sources support more folding than others, and some M functions just aren't foldable.
How do you know?
The sources talk about folding indicators in the query editor ribbon or status bar. You might see messages like view native query if it is folding, or sometimes indicators that folding is inconclusive or not folding.
And not folding means game over for folding.
Seeing not folding on a step doesn't necessarily mean zero folding is happening in the whole query up to that point, but it usually indicates that query folding stops at that specific step. Any steps after that point will be processed locally in the Power Query engine, which can significantly impact performance, especially on large data sets.
Is there a way to write a native query yourself, but still allow Power Query to potentially fold subsequent steps? Like inject some SQL but keep folding alive?
Yes, that's a more advanced technique using functions like value.nativeQuery. It allows you to provide a custom native query for the initial data extraction, and unlike just pasting a SQL query into a basic source step, which often breaks folding value, native query is designed to potentially allow subsequent Power Query steps to still fold against the results of that native query if possible.
Okay, interesting. Let's tackle a potentially frustrating one, the data privacy firewall, sometimes manifesting as formula, firewall errors. Why does this even exist, and why does it seem to block things that look perfectly fine to the user? It drives people nuts.
It can be a major source of frustration, absolutely. But the sources are clear on its purpose. It's fundamentally a security feature. It's designed to prevent unintentional or malicious data leakage between data sources that have different privacy levels assigned to them.
Data leakage, like accidentally sending internal data to a public API.
Precisely. Or even combining data between two different internal systems that shouldn't be mixed. The firewall enforces boundaries between what it calls data privacy partitions.
Partitions based on privacy levels. Public, organizational, private.
Exactly. Imagine you're connected to a highly sensitive internal database, maybe marked private, and also to a public website, marked public. The firewall's job is to prevent you from writing a query that takes data from the private source and somehow sends it or information derived from it to the public source during the query evaluation.
So it stops queries that try to phone home with sensitive info.
That's the kind of risk scenario it's designed to mitigate. The sources strongly emphasize the importance of network isolation for sensitive data, giving the example that if you connect to a sensitive OneDrive for Business and try to link it to Power BI, just isolating OneDrive isn't enough. Power BI itself, if handling sensitive data, might need network isolation like private links to prevent public internet access to its environment, further reinforcing the privacy boundary the firewall is trying to protect.
So it's about the entire data flow path.
Yes, and those common errors like formula.firewall. QueryX references other queries or steps, so it may not directly access a data source. Please rebuild this data combination, or privacy levels cannot be used together. Those are the firewall kicking in, indicating it sees a potential privacy violation in how you're trying to combine or reference data across partitions.
That makes a lot more sense when you understand the security context, even if the errors themselves are still a bit cryptic sometimes. Okay, how can you figure out where performance bottlenecks are or understand exactly how Power Query is evaluating your steps, including that folding aspect?
That's where Query Diagnostics comes in. It's an invaluable tool right in the Power Query Editor under the Tools tab. It logs detailed information about how your query is being evaluated.
What kind of info?
Things like how long each operation takes, where data is being retrieved from, source versus engine, how many bytes were transferred, and, critically, whether query folding was happening for specific operations.
And it has different views, summarized and detailed.
Yes, a summarized view, which kind of aggregates similar operations for a high-level overview, and a detailed view, which gives you granular information about every single background event Power Query performs.
How do you typically use it? Start, stop, diagnose.
Pretty much. You click Start Diagnostics, then perform the action you want to analyze, maybe refreshing a specific query preview in the editor, maybe refreshing the entire dataset in Power BI Desktop, or interacting with a step that feels slow. Then click Stop Diagnostics.
And the results appear.
The results are loaded into special diagnostic tables right there in your query editor that you can then analyze, often visually in a simple report or just by looking at the table data. You can also right-click a specific step and choose Diagnose Step to analyze just that one part.
And what are you looking for in those results? Big time sinks.
Exactly. You're looking at where the time is spent. Is it taking a long time retrieving data from the source? That might be solvable by improving query folding or maybe tuning the source database itself. Or is a specific transformation step in the Power Query engine consuming a lot of time? That might indicate an inefficient M pattern that you could rewrite.
Makes sense.
The sources also note that background operations like the editor automatically previewing the first 1,000 rows or doing background data type detection can cause extra requests to the source. There's an option in Power BI Desktop settings to disable some of this background analysis if you want a cleaner diagnostic picture focused purely on your explicit refresh actions.
That sounds essential for optimizing complex queries. Another best practice mentioned for performance and reusability, especially with slow sources, is separating data ingestion from transformation, particularly in data flows. What's that about?
This is a really smart architectural pattern. Instead of having multiple transformation queries and different reports or maybe different data flows all hitting a slow source system directly, you create one initial data flow whose sole purpose is to connect to that slow source and load the raw data into a staging area, often an Azure Data Lake Storage Gen 2 table if you're using Power BI Premium or Fabric.
Okay, an ingestion layer.
Right. Then any other data flows or even Power queries in Power BI Desktop that need that data don't connect to the original slow source anymore.
Right.
They connect to that fast reading stage table in the data lake.
So you only incur the cost, the time penalty of reading from the slow source once.
Exactly. The initial ingestion data flow might take time to refresh, but then all subsequent transformations and downstream data flows read from a fast, structured source in ADLS. This dramatically improves performance for the transformation steps and reduces the load on the original system. It also centralizes the connection and initial extraction logic.
That sounds like a very good pattern for enterprise scenarios. And parameters got another mention in relation to dynamic queries and that always allow privacy setting.
Yeah, parameters are key for making queries dynamic, allowing you to change source paths, filter values, or other parts of the query based on input without editing the M code directly. The always allow privacy setting, which you find in the data source settings, used cautiously, can sometimes help resolve firewall issues, particularly those involving parameters where Power Query struggles to determine the privacy implications.
Yes,
But,
there's always a but.
right, it essentially tells a firewall, trust me, ignore the privacy levels for this specific combination. This bypasses the safety check, so it comes with its own security implications. The sources advise using it with caution, and only when you fully understand the data flow and are sure there's no risk of leakage.
Okay, so use with extreme care. We've seen how Power Query works at the desktop level, the language behind it, and performance considerations. Let's talk about scaling this up with data flows.
Data flows essentially take the Power Query experience and lift it into online services. Think Power BI Service, Power Apps, Dynamics 365 Customer Insights, Azure Data Factory, Microsoft Fabric.
So it's Power Query, but shareable and schedulable in the cloud.
That's a good way to put it. They allow you to perform these data preparation steps in the cloud, independent of a specific report file or desktop instance. This creates reusable data preparation logic that can be consumed by multiple reports, apps, or other downstream processes.
Are there different flavors or requirements?
The environment context is important, yes. Using data flows, especially features like saving to data lake storage, direct link mode in Fabric, or certain connectors, might have licensing requirements like Power BI Premium, Fabric capacity, or specific Power Apps plans.
Okay. Incremental refresh in data flows sounds like a major benefit for large data sets. How does that work?
It absolutely is. For large tables, doing a full refresh every time, pulling all the historical data, is often inefficient and slow. Incremental refresh tells the data flow to only refresh view or change data since the last refresh, based on a date or date-time field in your source data.
What's the key requirement for that? Got to have a date column.
You got it. Your source table must have a column of the date or date-time type that Power Query can use to filter the rows to be included in each refresh partition. You define the rules in the data flow settings, like refresh the last 7 days of data and store the last 2 years.
Is it set up for the whole data flow or table by table?
It's configured at the individual table level within the data flow. So you can have some smaller tables doing a full refresh, and your big fact tables configured for incremental refresh.
What happens if you decide to switch a table that's been incrementally refreshing back to a full refresh? Does it wipe the history?
Yes. The sources note that performing a full refresh on a table previously configured for incremental refresh will overwrite all historical data that was built up by the incremental process within the data flow storage. You'll typically get a warning asking you to confirm this.
Good to know.
It also notes that the filtering for incremental refresh is dependent on the time the refresh is run, which is a detail to be aware of for data consistency over time, especially around date boundaries.
Makes sense. Managing connections is a bit different in data flows too, more centralized.
Yes, connections and data flows are managed centrally within the service. Each connection has a unique identifier and associated credentials, often using a gateway for on-prem sources. You can actually create multiple distinct connections to the same data source if you need to use different credentials for different purposes or users, which is quite flexible.
And if things go wrong with data flows, the sources had a few troubleshooting tips. Gateway updates, workspace versions.
First, basic maintenance.
Hmm.
Always ensure your data gateway is up to date if you're connecting to on-premises sources. Many issues are resolved in later gateway versions.
Standard IT advice, keep stuff updated.
Pretty much. If you find yourself with limited options when creating data flows, especially in Power BI, you might be in an older V1 workspace and need to upgrade it to a modern V2 workspace or Fabric workspace to get all the features.
And what about trimming data source bindings? That sounds like a specific weird fix.
It is. It's a troubleshooting technique specifically mentioned for resolving certain stubborn connection issues in the Power BI service. It involves going into the data flow settings, temporarily switching the assigned gateway to a different one, even if it's not the right one, saving, and then switching it back to the correct gateway and re-entering credentials.
Why does that work?
This action essentially forces the service to delete and recreate the underlying data source bindings, which can clear up configuration glitches or cached information that might be causing the problem. Also, a key limitation noted is that data flows are not automatically copied when you copy a Power Platform environment, which is important to remember for application lifecycle management. You need to handle their deployment separately.
Good to know the quirks. And you can monitor data flow refreshes, see if they succeeded or failed.
Yes, you can set up monitoring. The service provides refresh history, and you can also use tools like the Power BI REST APIs or build custom monitoring reports, perhaps using a streaming dataset in Power BI to track the refresh duration and success failure status of your data flows in near real time.
Finally, loading data from a data flow into Dataverse, Microsoft's application platform database, had some specific points about keys.
Right. When mapping your data flow output to a Dataverse table, you need to define how records are uniquely identified in the destination table, so the data flow knows whether to update an existing record or insert a new one.
How do you do that?
You can use Dataverse's unique primary name column, an alternate key you've defined, which is a set of one or more columns that uniquely identify a record, or a composite key. There's also an important option to select if you want to delete rows that no longer exist in the query output.
Ah, so it can clean up old records in Dataverse automatically.
Exactly. This keeps the target table perfectly synchronized with the data flow's output, but it does add processing time during refresh because Power Query has to compare the current data flow output against the existing Dataverse rows using the key you defined to figure out which ones to delete.
Wow, okay. We have really journeyed through the landscape of Power Query and M here. It's quite a lot under the hood.
We started by acknowledging that significant challenge of data preparation and saw how Power Query tackles it head-on, providing accessible tools for connecting and transforming data through its, pretty intuitive user interface.
We pulled back the curtain to explore the Power Query M language, understanding its structure with let expressions, its value types, operators, and powerful functions, and crucially, how it handles errors with try.
And we dove into crucial operational aspects, understanding how to optimize performance using query folding, navigating the sometimes tricky security guardrails of the data privacy firewall, diagnosing issues, and scaling data preparation with data flows.
It's clear that Power Query, backed by the M language, is a really robust engine for tackling complex data wrangling challenges. While the UI gets you incredibly far, understanding the underlying M recipe and concepts like query folding and the firewall is really key to building efficient, robust, and understandable data pipelines, isn't it?
Absolutely. We've touched on just how deep the M function library is and the sheer range of capabilities built into Power Query, even things we only briefly mentioned like fuzzy matching or schema view.
So let's leave you with this final thought. We've seen how Power Query offers tools for everything from splitting text and parsing JSON to fuzzy matching data and handling complex join scenarios using the UI. But think about a specific data transformation problem that feels tricky or overly manual in your current workflow right now. Maybe it involves cleaning up really inconsistent text, combining data in a non-standard way, or dealing with a source format that's just not a simple table. Could a deeper exploration of Power Query's vast M function library, perhaps looking at functions designed for more niche tasks than the core UI buttons cover, things like binary manipulation or list transformations, or even thinking about building your own custom function to encapsulate a repetitive bit of logic? Could that unlock a surprising or much more efficient way to solve that specific problem?
The M recipe is there, waiting for you to get creative. The potential to automate and refine those tricky transformations is immense once you start exploring beyond the surface clicks.